Stop before you scroll past this. I need you to understand something. Everything you have ever seen, everyone you have ever loved, every war ever fought, every dream ever dreamed, all of it happened on something so small that from the edge of our own solar system, it completely disappears. That is not an exaggeration. That is a photograph NASA actually took. In this video, we are going to travel from Earth all the way to the edge of everything that exists, and I promise you one thing, the way you see yourself and this world will never be the same after this.
Stop. I need you to actually stop whatever you're doing and pay attention for the next 10 minutes, because what I'm about to show you is going to permanently change the way you see yourself. Not in a motivational way, not in a "you are special" way, in a cold, scientific, slightly terrifying way. Because right now, in this exact moment, you believe you understand the scale of reality. You don't. Nobody does. And when you see what I'm about to show you, you'll understand why. Let's start with something familiar, something you've lived on your entire life: Earth. Right now you are standing on a rock, a spinning, hurtling rock, moving through space at 67,000 miles per hour. You can't feel it, you can't sense it, but it never stops. This planet, your entire world, is about 8,000 miles across. That sounds enormous, and to us, it is. Every mountain you've seen, every ocean, every city, every war ever fought, every human being who ever lived, all of it happened on this 8,000-mile rock. The deepest hole humans have ever drilled into the Earth is called the Kola Super Deep Borehole in Russia. Scientists worked on it for over 20 years, and when they finally stopped, they had gone about 7 miles deep. Out of 4,000 miles to the center of the Earth. They drilled for 20 years and barely scratched the surface, literally. We haven't fully explored our own planet. We haven't even come close. And yet, compared to everything else in our solar system, Earth is almost nothing. Here's where your brain starts to struggle. Our sun. You've seen it your whole life. It looks like a glowing circle in the sky, something you're warned not to stare at, something that rises and sets every single day. But let me tell you what it actually is. The sun is so massive, so incomprehensibly large, that if you hollowed it out like a basketball, you could fit 1.3 million Earths inside it. Not 1,000, not 10,000, 1.3 million Earths. Think about that. Take everything you've ever known, every person, every country, every ocean, and multiply it by 1 million. You still haven't filled the sun. The surface temperature of the sun is about 10,000 degrees Fahrenheit, but the outer atmosphere, the corona, reaches temperatures of 3.5 million degrees. Scientists still don't fully understand why. The sun regularly launches massive explosions into space called solar flares. If Earth took a direct hit from a large one, it could knock out every power grid on the planet within hours. No electricity, no internet, no water, no supply chains. Civilization as we know it would begin collapsing within weeks. And here's the humbling part. The sun is not a large star. Among all the stars in our galaxy, our sun is considered small to average. There are stars out there that make our sun look like a marble next to a hot air balloon. Let's zoom out further. Our solar system. 8 planets, billions of asteroids, trillions of comets, all orbiting one star. Here's what every map of the solar system gets wrong. Every textbook, every poster, every diagram you've ever seen, they're all lying to you about one thing. Our solar system is almost entirely empty space. If you shrunk the sun down to the size of a basketball and placed it in the middle of a field, Earth would be a tiny ball bearing, barely visible, sitting about 80 feet away. Mars would be another 40 feet beyond that. Jupiter, the largest planet, would be a marble sitting 400 feet from the sun. Neptune would be a tiny bead, 3/4 of a mile away. Everything in between? Nothing. Cold, silent, absolute vacuum. We launched a spacecraft called Voyager 1 in 1977. It has been traveling for nearly 50 years. It is the farthest human-made object ever built, and at the speed it's traveling, 38,000 miles per hour, it would take Voyager 1 over 73,000 years to reach the nearest star to our sun. 73,000 years. At 38,000 miles per hour. Space isn't just big. It's a completely different category of distance that the human mind was never designed to process. I want you to do something tonight. Go outside. Find the darkest spot you can. Look up. On a perfectly clear night, the human eye can see roughly 5,000 stars. 5,000. That's it. That's everything your biology allows you to see of the universe around you. Now here's what those 5,000 stars actually represent. Our galaxy, the Milky Way, contains between 200 and 400 billion stars. Not millions, billions. Every single one of those stars is a sun, and most of them have planets orbiting around them, which means our galaxy alone likely contains hundreds of billions of worlds. Some of those stars are so enormous they shatter comprehension entirely. Take a star called Scuti, one of the largest stars ever discovered. If you replaced our sun with Scuti, it would swallow Mercury, Venus, Earth, Mars, the entire asteroid belt, and extend almost to Jupiter. Our entire inner solar system, swallowed inside one star. And yet, with all of that, the Milky Way is not a special galaxy. It is not remarkable. It is one ordinary galaxy among 2 trillion. The Milky Way is a barred spiral galaxy, a massive rotating disk of stars, gas, and dust, roughly 100,000 light-years across. That means it takes light, traveling at 186,000 miles per second, the fastest speed anything can move. It takes light 100,000 years just to cross our galaxy from one side to the other. Our sun sits about 26,000 light-years from the galactic center, tucked in the middle of an unremarkable spiral arm. We are not near the center. We are not near the edge. We are in the cosmic suburbs, the equivalent of a mid-sized town no one's ever heard of. At the very center of the Milky Way sits a supermassive black hole called Sagittarius A star. It contains the mass of 4 million suns. Entire stars orbit around it at millions of miles per hour, completing full orbits in just a few years. And from Earth, we can't even see it. There's too much interstellar dust blocking our view. We live inside this galaxy, and we're essentially blind to its own heart. That's the scale of the thing we call home. Here's something that doesn't get talked about enough. Right now, at this very second, another galaxy is heading directly toward us. The Andromeda galaxy. It contains about 1 trillion stars. It sits 2.5 million light-years away, and it is moving toward the Milky Way at roughly 70 miles per second. In about 4.5 billion years, these two galaxies will collide and merge. That sounds catastrophic. But here's the strange part. Because galaxies are mostly empty space, the actual stars are very unlikely to physically smash into each other. Instead, the two galaxies will pass through one another, be pulled back by gravity, and slowly merge over billions of years into one giant galaxy. Scientists have already nicknamed it Milkomeda. By the time this happens, our sun will have already expanded into a red giant and vaporized Earth. The merger is coming. It has been scheduled for billions of years, whether anything is here to witness it or not. Okay, now let's go all the way. Past the Milky Way, past Andromeda, past our local group, past the supercluster we belong to, a structure called Laniakea, containing over 100,000 galaxies. The Observable Universe. The Observable Universe is the region of space we can theoretically detect from Earth, limited by the speed of light and the age of the universe. It contains an estimated 2 trillion galaxies. 2 trillion galaxies, each one containing hundreds of billions of stars. Each star potentially having its own planets, each planet a possible world. The observable universe is approximately 93 billion light-years across, meaning even if you could travel at the speed of light, the absolute maximum speed allowed by physics, it would take you 93 billion years to cross it. The universe itself is only 13.8 billion years old. You could not have crossed the observable universe in the entire history of time, even at light speed. And here's the part that genuinely disturbs astrophysicists. The observable universe is just the part we can see. The full universe, the real, total, complete thing, is almost certainly vastly larger. Some models suggest it could be infinite. No edge, no boundary, no wall at the end. Just space, continuing forever, in every direction, without end. So what's outside the observable universe? Honestly, we don't know. And that is the truthful scientific answer, the honest frontier of human knowledge. But physicists have theories, and some of them are stranger than anything science fiction has ever imagined. One leading theory, called eternal inflation, suggests that our universe is just one bubble in an infinite ocean of universes, each one born from a quantum fluctuation in the fabric of space, each one potentially having different physical constants, different laws of physics, different rules for how matter behaves, how energy works, how time flows. In some of those universes, the constants might not allow stars to ever form. No stars, no planets, no chemistry, no life. No one to ever know that universe existed. It would be born, expand forever in perfect darkness, and die without a single mind ever arising to notice it. In others, gravity might be too strong. Everything collapses into black holes before galaxies can even form. And then there is this universe, our universe, with exactly the right balance of forces, all tuned perfectly to allow stars to burn, planets to cool, chemistry to grow complex, and evolution to do its slow, patient, extraordinary work. We don't know if other universes exist. We may never know. But the math doesn't rule it out, and for some scientists, it actively predicts it. So let me bring you back down, back to Earth, back to this pale blue dot, back to you, sitting wherever you are right now. Everything I just showed you is real. The numbers are real. The distances are measured. The galaxies are cataloged. This is not metaphor. This is not exaggeration. This is the actual, confirmed, observable nature of physical reality. And in the context of all of it, all 2 trillion galaxies, all 93 billion light years, all the time and space that exists, you are almost infinitely small. Your entire life, every relationship, every heartbreak, every moment of joy or love or fear, it all plays out on a microscopic rock, circling an average star in the outer arm of one unremarkable galaxy, among 2 trillion others. That should feel humbling, maybe even a little terrifying. But here's the other way to hold this. You are the universe looking at itself. Every atom in your body, the carbon in your cells, the iron in your blood, the calcium in your bones, the oxygen you just breathed in, all of it was forged inside a dying star, billions of years ago. When those stars exploded, they scattered those atoms across space. Gravity gathered them, chemistry built complexity, evolution built brains, and here you are. You are made of star stuff, literally, not poetically, literally. And more than that, you are one of the only things in the known universe that can look up at those stars and actually understand what they are. Measure their distance, calculate their age, wonder about what lies beyond them. Think about how improbable that is. How many billions of years, how many supernovae, how many lucky accidents of chemistry and evolution had to happen precisely the right way for a conscious, questioning, feeling being to exist. The universe didn't have to make something capable of understanding it, but it did. And somehow, impossibly, that something is you. So yeah, you are small. You are a microscopic story in an incomprehensible cosmos. But you're a conscious one. You are the universe's way of knowing that it exists. And as far as we know, that makes all the difference. If that broke your brain a little, good. That was the whole point. Share this with someone who needs a new perspective on their problems today. And if you want more, subscribe. We do this every single week. Next time, what actually happens at the edge of a black hole, and why time itself breaks down. See you there.